This problem's about an open top box. A lot of the information is already in the diagram for us. We are told that we have 100 square inches of tile and that we want to find the dimensions that has the greatest possible volume. So as we start this problem, we're going to first start by writing down what it is we're trying to achieve, which is to maximize volume, which means we want to write an equation for the volume of this box. So volume equals, let's see, our base, W times 3W, times our height. And we look at this and we see, okay, we've got one too many variables. So we look for another clue and we realize we haven't used that clue yet about the 100 square inches. And we remember that it's also an open top box. So we're going to have 5 sides. So our area includes a bottom, and our bottom right here is 3W times W, or 3W squared. And we have one of those. It includes the left and the right side, which are these ones, which are W by H. We have 2 of those. And it includes the front and back, and those are 3Ws by H's. So you can see that there's 3 here, and then another 3 back here, for a total of 6WH on the front and back. And that area is limited to 100. And so we've got 3W squared plus 8WH. All right, so we could solve for W or H, but clearly H is much easier to solve for. So we're going to do that. 100 minus 3W squared all over 8W gives us H. And now we're going to plug that in right over here. So we've got volume equals W times 3W times 100 minus 3W squared all over 8W. Now you might wonder why I hadn't multiplied this out. I kind of saw what was coming up, and I was like, oh, I can cancel with these W's. There we go. That's nice and easy. And before I differentiate, I want to make this look a little cleaner. Let's see, I have a constant 3 over 8 that I can just put out front. I'm going to do that. But this W, I'm actually going to distribute it, so it's going to make a nice, easy derivative. So I'm going to have 100W minus 3W cubed. All right, now I've got myself set up for a super easy derivative, dV dW. My constant just stays there. My derivative, 100 minus 9W squared. I now want a critical number, so I set this thing equal to 0. I can see that 100 equals 9W squared. And let's see, pop up here, W squared equals 100 over 9. Perfect squares, yay. W equals 10/3. I have found my critical number, yay. So that must be where my answer is. And I go back and read the question. What did it ask for? It asked for dimensions. All right, so my width is 10/3, what I found right here. My length is 3 times that, so 10/3 by, well, 3 times that's just 10. By the way, everything in here is inches, so 10/3 inches, 10 inches by, and my height. Okay, I know this 10/3, and here's the formula. Now, I'm not going to spend all the time doing all the math, but you can do it, and it turns out that if you do all of this and do all your math right, it does come out to be 2.5. So by 2.5 inches. And that's that problem done.